To solve a problem of quadratic expression with the value of a not being equal to 1, you need to consider the following. First, consider AC. Instead of just considering C the way it was when the value of a was equal to 1, when it is no longer equal to 1, we consider AC. And in the problem we have above, when considering AC, it means we are multiplying 3 and negative 1. So it means that our AC will be negative 3. Now remember also that when we dealt with quadratic expressions when a was equal to 1, we used the expression x squared plus open bracket alpha add beta close the bracket x plus alpha times beta to work it out. In that case, our alpha times beta was c, but this time around our alpha times beta is no longer c but ac. We should have that in mind. Next, initially there was nothing attached to our x squared because the value of a was just 1. But this time around, when the value of a is not equal to 1, it is important to carry a along. So the formula adjusts to ax squared plus open bracket alpha plus beta close the bracket x plus alpha times beta. Something important you should take note of right now is that alpha and this a are not the same. A is just the coefficient of the x squared that we had initially, but alpha is the factor you are looking for. Most of the time they're exactly the same thing, but they are not always the same. So take note, this is my major reason for not using a inside my bracket, so that learners will not confuse which one is the factor and which one is the coefficient of x squared. Having said that, let's apply this method as we want to solve this problem. Since k is your known variable we are dealing with, I am going to change x to k in this expression written down here. So it's going to be ak squared plus open bracket alpha add beta with k representing x plus alpha beta. Remember, alpha beta is no longer c but ac. So with that in mind, my ak squared comes down as 3k squared plus open bracket. Now I want to look for the factors as usual, that when I add them together, it's going to give me addition of 2, that is positive 2. But the same factors when multiplied together will give me, remember AC, will give me negative 3. Meanwhile, I just keep my negative 1 right there. Don't forget about that. So our focus is inside the bracket. Therefore, let's think. The factors we are looking for are 3 and negative 1, because we know that when we add 3 and negative 1, that is obviously going to give us positive 2. And when we multiply 3 and negative 1, that's going to give us the value of AC, which we already explained right here. So since we already have this, this will turn out being 3k squared plus 3 times k will give us 3k, and then minus 1 times k is 1k, or just write it as k, now minus 1. With this, we can now proceed to deal with factorization by grouping. So let's do that immediately. I'll just come up here and make it work. Factorization by grouping requires us to group 3k squared plus 3k going together and negative k and negative 1 going together. With that in mind, if I look at 3k squared, I know that the common factor is 3k. So 3k going to k will give us 3k squared. Add 3k going to 1 will give me 3k. That is done already. For negative k and negative 1, the highest common factor is negative 1. So that negative 1 times k will give me negative k. And negative 1 times positive 1 will give me negative 1 back. Now notice that both brackets are the same. So once it happens like that, you factor out that bracket. K plus 1, one bracket, while whatever is remaining 3k and negative 1 take over the next bracket. This becomes our factorized form for 3k squared plus 2k minus 1. To check if you actually got the answer right, all you need to do is to expand this bracket. And when expanded, notice that k times 3k is 3k squared. K times negative 1 is negative 1k. Negative 1k add 1 times 3k will give you positive 2k. And then 1 times negative 1 will give you negative 1. Now look at the question, look at the answer. Compare them and notice that we have factorized it correctly. For a case involving 6x squared add 7x minus 20, the very first thing we do here is to look for the value of AC. And the value of AC will be 6 times negative 20. 6 times 2 is 12. So that is going to give us 6 times 20 will give us negative 120. Now, the next question we need to ask ourselves, considering the way to write the expression in mind, is what two factors will I add together to give me 7 and at the same time multiply them together to give me negative 120? If you give it a thorough thought, you would notice that 15 add negative 8 will give us 7 positive. And at the same time, 15 multiplies negative 8 will give us negative 120. So what it means is that the factors we are looking at are 15 and negative 8. Having said that, we can easily substitute it into the expression we have above as 6x squared. 7x now changes to 15x subtract 8x minus 20. So when this is the case, all we need to do now is to factorize by grouping. 6x and 15x have a common factor of 3x. So 3x times 2x will give us 6x squared. And then 3x times 5 will give us 15. For this part, we notice that negative 4 is common between negative 8x and negative 20. Negative 4 multiplies 2x gives us negative 8x. Negative multiplies positive is the negative you have here. So 4 times 5 is 20. With both brackets being exactly the same thing, you factor it out as 2x plus 5 inside one bracket. And then the remaining bracket takes up 3x minus 4. This is the finalized factored form of 6x squared plus 7x minus 20. Do you see how easy it is? Our last example for today says we should factorize 8x squared plus 34x plus 35. Taking a good look at this, it's really big. So one thing we can do to help us is go ahead with the AC first of all. So solution. We go ahead with finding the value of AC. Here you notice that our AC is the same as 8 multiplied 35. 35 multiplied 2 is going to give us 70. So 70 multiplied 4, that is 280. All right, 280. That is what AC gives us. So all we need to do this time around is to think of two different numbers that when multiplied together gives you 280. But the same 8 and 35 can't do that because 8 add 35 is not going to give us 34. But what about numbers like 20 and 14? Yes, 20 and 14 should be able to work that out because 1410 is 140. 140 times 2 will give you 280. So 20 and 14 should do that. So we just need to change 34x to 20x plus 14x this way. 8x squared, which is written here, and instead of writing 34x, I just change it to 20x add 14x. And then our 35 comes down. Our 35 is right down. At this stage, go straight to factorization by grouping. If we group this, notice that we have 8x squared and 20x. For 8 and 20, what is common first of all is 4. X squared and x have x as common at the same time. So 4x go into 2x gives us 8x squared. And then 4x goes into 5 will give us 20x. This part is already factorized. For the second part, since both of them are positive, we just look for what is common between them. I think the number 7 is common. So we go with the number 7. Add 7. Open bracket. How many 7s we go into 14x? 2x 7s. Plus, how many 7s we go into 35? That is 5. At this stage, notice that the brackets are also the same. When this is the case, you factor out one of the brackets. So we have 2x plus 5 right down here, while the next bracket takes up 4x and 7. 4x add 7. This is already factorized. You can try expanding this last bracket to see if it gives you 8x squared plus 34x plus 35. If you are able to get that answer right, know that this works. And exactly it is going to work. This is how easy it is when you are dealing with quadratic expressions when it comes to factorizing them. Take note of the minor differences that exist when a is equal to 1 and when a is not equal to 1. More practice will help you to grasp exactly what differences exist between the two methods. And as always, thanks for watching.